Hello, and welcome everyone to this past marathon containers edition. We're excited you could join us today for Paul Stanton's session, Data Delivery Using Database Clones with SQL Server Containers. This past marathon features back-to-back live webinars delivered by expert speakers from the PaaS community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name is Jan Mulkens. I'm a speaker at European conferences, an organizer for 2 Belgian user groups, and the organizer of Power BI Days, a free 2-day conference you can either attend live in Belgium or virtually via www.powerbidays.com. I have a few introductory slides before I hand over the reins to Paul. So, Paul, next please. Thank you. If you require technical assistance, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to answer your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to Paul. You are able to zoom in on the presentation content by using the Zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. This will pop up after the webinar ends in your web browser. Your feedback is important to us, so please take a moment to complete it. Next slide, please, Paul. Thank you. So you can gain access to even more in-depth learning by registering for PaaS Summit today. It's taking place on November 6th to 9th in Seattle, Washington, and PaaS Summit will help you gain the technical skills and connections needed to advance your data career. Visit paassummit.com or scan the attached QR code to gain more information. And we hope to see you at this year's PaaS Summit. This PaaS Marathon session is presented by Paul Stanton. So without further ado, here is Paul with data delivery using database clones with SQL Server containers.
Thank you, Jan. Really pleased to be here today to talk about database cloning and use with Docker SQL Server containers. I'm with a company comprised of former Microsoft engineers. We date back some time, as you can see on this slide, but more recently I've been totally focused on containers and was involved in software startups that were focused on containers prior to the emergence of Docker. I was actually there when Solomon Hykes announced Docker. And for the past several years, we've been focused on delivery of Docker to Windows. Now, in this session, we're going to talk about database cloning for Docker SQL Server containers. And I want to just clarify that Windocs is both an independent port of Docker to Windows, and so you can run SQL Server containers on Windocs itself, as well as being a full-featured database cloning engine. And that database cloning engine, we now support delivery to all SQL Server targets, so SQL Server containers as well as instances. And we're going to talk about database cloning in general, and we'll see some demonstrations of the Windocs as it supports delivery of large database environments to SQL 2017 on Linux and other environments. And I think it's important to think about the reasons that we're attracted to SQL Server containers is for the agility, the fast delivery of these application environments. When paired with .NET or Java front-end containers, it really provides full stack, agile software development, testing, and delivery. But we firmly believe that containers without the database environments is analogous to a rocket ship without a payload. So in this session, we're going to focus on how do we deliver full production scale data environments for SQL Server containers. And during this session, we're going to take a look at the motivation for database cloning. We're going to take a look at the specifics of what amounts to a database clone. We'll talk about the pros and cons offered by clones and alternatives, and we'll wrap up with some hands-on demonstrations on the use of clones. Database cloning has been around in the marketplace, particularly on storage arrays, for the past couple of decades. When storage array networks were first brought to market, and through to today, storage arrays all support fast volume-based cloning. So you can take a volume on a storage array, you can clone it, and that clone can be exposed to being used by SQL Server and other application environments. And what we're going to focus on much of in today's discussion is the use of Windows-based database cloning. And they both storage arrays as well as Windows-based database cloning allow the delivery of terabyte class databases in seconds. Generally in 30 to 45 seconds, you can have multi-terabyte class environments delivered to your container. These environments support read and write. They support complex database environments that can include up to 50 or more databases in a single image. These environments can also support external key managers, SQL Server TDE encryption, and any number of other enterprise infrastructure and processes. This technology is widely used today. It's been available from Redgate does SQL clone. Windox has a cloning engine that supports containers. Both of those products were released in early 2017. And in the discussion today, we're going to talk about how database clones can be built into Docker images. And this enhances security and data governance by creating immutable, auditable artifacts that can incorporate the security policies of the organization behind them. And another important aspect is how database clones really enables more freedom to individuals and teams. The tooling that we're going to take a look at today can be used with any storage array or use of SQL Server backups and delivers to any target environment. It all can be managed by a SQL Server DBA or developer, and it's independent of storage admins. So it really reduces the organizational friction that I see commonly in teams where you're commonly dealing with a storage admin, with Windows admins, with SQL Server DBAs, and there's the need to put together some pretty complex PowerShell scripting to merge these environments together. What we're going to look at today is really a simpler approach to that problem. So let's take a look at a database clone in the Windows parlance is really a Windows virtual hard drive, which is a file that encapsulates a virtual disk. Windows virtual hard drives are foundational to Hyper-V VMs, but the VHD is built into the Windows operating system. You can easily work with VHDs on Windows 10 or Windows Server 2012 or 2016. And the VHDs then in turn support the creation of additional VHDs, which are called differencing disks. And these differencing disks are going to be called clones in this discussion. And they are thin provisioned copies with read-only file pointers to the parent VHD. So as we discuss Windows-based database cloning, we'll always be talking about two different types of VHDs. There's a parent VHD, and that is the database image in the discussion of a Docker image. That parent VHD is a full byte copy of the data environment. As I said earlier, it could be one database or it could be up to 50 or more databases. And that parent VHD becomes a read-only source for differencing disks, which are the clones. The clones are support full read and write support, but they expand dynamically with a copy on write design. The clones are delivered very quickly. They occupy less than 40 megabytes of storage on delivery, and they're really ideal for most development and test purposes. As I mentioned, VHDs are part of Windows, and they often are associated with Hyper-V support, but wherever Windows servers are supported, you can build VHDs. The technology that we're going to look at today runs equally well on AWS as it does on Azure, and it runs on any on-premise infrastructure as well. And as I mentioned earlier, while we're going to focus on Windows-based cloning today, any storage array appliance will support similar snapshot and cloning capabilities. And they all employ various similar designs where the file pointers are pointing to a source volume. They're a thin provisioned clone in the same way that the Windows clones are. In the discussion today, we're going to focus on the use of backups, but whether it's a backup or the actual databases themselves in the form of a snapshot, the workflow is to restore these backups to a VHD. The VHD that the databases are restored to ultimately is saved and becomes a VHD parent image, which in turn then supports the delivery of clones. And the clones are then mounted to your target SQL Server environments. The target environments can be SQL Server instances, or in our discussion today, obviously, we're going to focus on delivery to SQL Server containers. Database clones have their pros and cons. They're very fast, economical, and horizontally scalable, and a very lightweight process. As I mentioned earlier, they're really ideal for supporting development and test teams. They also can be used for ETL and reporting purposes. They're flexible in the sense that you can use these clones with a Docker command line. They can be incorporated into a continuous integration pipeline using Jenkins or TeamCity or other CI servers, but they also can be used to support just user-driven container with data provisioning. As I mentioned earlier, one of the benefits is that this tooling really supports independence from storage admins. So really frees the admin from having to attend to SQL DBA's needs. And it supports really any target that you want to work with, SQL Server instances as well as containers for a complete data service or a data delivery strategy. The downside of a Windows VHD clone is that it does require time to restore the backups into the VHD. So the original image build, the VHD parent, will require whatever time is normally associated with restoring the backups on your infrastructure. In very large environments, this obviously can take some time, and that's the reason why commonly the VHD parent image is built during off hours. Clones also represent an environment where the clones are sharing a parent disk and really are not suited for production use today or for stress testing, particularly because of that design. So it's helpful to keep in mind that clones are extremely valuable for a broad range of uses, but they're not for all purposes. Now, I'm sure you're all aware, and actually, Jan, it'd be really helpful to run that survey now just to get a sense for, among our audience, who's using Docker in their day-to-day work. Can you do that, please?
Yeah, just started it. Everybody should now see a poll on the screen asking you whether you use SQL Server containers in your day-to-day work. So please just select yes or no. I'll keep the poll up for about 15 more seconds. About 5 more seconds until closing the poll. And you're too late. Well, most people voted anyway. About 70% of the people voted, with most of them in the first 30 seconds. About 4% of the attendees use SQL Server containers in their day-to-day work.
Yeah, okay, that's good to know. It's very consistent with what we're seeing. We're seeing a lot of people that are learning about containers. There's not what I would call very widespread use today, although it is growing at a pretty rapid rate. Clearly, people that are looking to migrate to SQL Server 2017, a lot of interest is being sparked by SQL Server 2017 support on Linux, and containers are a preferred environment on the Linux platform. So I expect that the actual usage is growing and will continue to grow for some time in the future. So let's talk about the alternative methods available apart from database cloning. Docker containers all include a local container file system. Each container has its own file system. It's isolated from the host file system environment. And these work really well for relatively small data environments. We have customers that work with these, but from a practical point of view, it would be unusual for people to use the local file system for database environments greater than perhaps a gigabyte in size. And that's primarily for storage efficiency, but also for the time involved in simply copying the data set on the creation of each new container. The other alternatives, which I'm sure you've seen many demonstrations in the earlier sessions today, will focus on mounting to either local or network-based volumes. The volumes would have the databases that are mounted to the container. And this is a great solution, but again, each either the network attached volume will be reused when the container environment is discarded. The volume mount point can be reused and reattached to another container. And with any volume of containers, it does involve some complexity where you're going to have multiple volumes with multiple mount points, and managing the dynamic nature of the workflow can be challenging for this. Obviously, it can be scripted with PowerShell, but that is the practical considerations there. So if you can have the storage and the ability to clone volumes, and create multiple mount points for multiple containers, that can be a good solution. This is also something that is enhanced with fast flash-based storage arrays. Is an environment where this is typically better suited than many workstations. And the third option is database cloning, which is our focus today. So let's take a look at the workflow of building a database clone. And here I'm going to take a look at a Docker-oriented workflow. On the left-hand side, we have a Docker host. In this case, it would be a Windows server that supports this database cloning process. You can think of the Windows server as really being a data service server. And on the right-hand side, on the bottom right, is a Docker client, and we're going to build a Docker file. And so you can see we're going to do a build -t on a Docker file, and we're going to create an image called clone. And in this case, the Docker file is relatively simple. It is building a image based on SQL Server 2016, and the Windows cloning engine has some SQL Server specific extensions built, and one of them is the setup cloning command. There's setup cloning full as well as diff for differential backups. In this case, we have setup cloning full for a couple of full backups. One is called sales and one is ops. And you can see that we have a universal file path exposed, displaying the path to the backups. And then finally, we're going to copy and run a SQL Server script on this image as we build it. And that context of the Docker file is sent to the engine. The first thing the engine is going to do is it's going to build a SQL 2016 container. And then it realizes that it's building a clone image, a clonable image. And so we'll build the VHD. The VHD has to be created. And the VHD is created, in our case, we automate the creation to be wherever the first backup is located. So the VHD is going to be located where the test sales backup is out on the test backups folder. And once that VHD is built, then we mount it to the SQL Server container, and then we restore the backups into that VHD. And when that is complete, then the scripts are run against the databases there. When that is all complete, then the VHD is unmounted and saved and becomes part of the image that we've built. In this case, the image is called clone. This is just an example of a Docker file that we just took a look at. In this case, the Docker file is building a full clonable image with 3 backups. These backups are local to the host located in the Windocs DB backups folder. And that is where the VHD will be built. So the VHD is going to be located in the same location as the backups, and a network-based backup will use universal file paths. Another example of a Docker file is presented here. And in this case, we're building a image that will deliver the data to a SQL 2017 Linux container. So as all Docker files will begin with a from image name. And in this case, the following operations is to set up cloning full with these 3 target databases. The databases are located on the host. And then in the Windocs data engine, we have an environment variable called use Docker file to create container. And this environment variable allows us to recognize a Docker file that needs to be saved as part of an image. So you can imagine that in this image, we're going to repetitively make Docker commands, calls to the Linux Docker host to create a new container. And so we use this environment variable to actually save these commands as part of the image. And this allows us to get around some of the limitations of Docker. Normally, Docker, in working with mounted resources, you aren't able to save this type of information in an image. You would actually be running a Docker file individually every time you wanted to execute these commands. Our customers have asked us to simplify the process to create a more usable workflow. And so this is what we've done to address that need, to create an environment variable where we can designate a Docker file set of commands that will be run at runtime for the delivery of the data environment. You'll also notice that this Docker file implicitly now is defining both a source of data as well as the delivery of the data to a target. So you can see the command run target attach MS container SQL Linux. In that, we're identifying to the engine that, hey, these are commands that are specific. The parameters needed are specific to executing a series of commands that provide runtime and build time parameters to create the environment on the Linux SQL Server container host. So you'll note that certain of the command parameters are build time parameters. So the target host IP and port is saved as part of the build time parameters. The target SQL Server image is a build time parameter, but the runtime parameters will include a user assigned container port, a user assigned SA password, and with those, we'll be able to deliver this environment. Jan, are there any questions that are coming through at this point? Okay. Here's another example of a Docker file that is taking clones and sourcing the clones from one environment and delivering them to another. So in this case, this Docker file is really designed to support the delivery of clones from a pure storage array. So in a very similar fashion to the Docker file we just looked at, this Docker file supports the creation of a clone on a pure storage array. And you notice that the parameters are all itemized and presented vertically. Now, the format here is not your standard Docker format. I've put the parameters into a vertical order for readability. Normally, these would be, included in a more stringified form. But you can see that the pure storage array has a source volume that is targeted for cloning. We create a destination volume with a container ID. We create a mount point on the Windocs data delivery platform. And the storage array has a host name, an IP address, as well as a username and password. Now you notice that in this case, I'm calling out the password as being encrypted. The Windocs engine includes support for encrypted credential secrets. So there's no need to have plain text passwords included in a Docker file with this solution. Now, like we did earlier, you can see the same parameters are being presented for the SQL Server Linux host. And then down below, we've itemized the databases that are to be mounted to the target environment. So in this case, it's a dummy set of databases, DB1, 2, and 3. And so now I'm gonna switch gears and let's take a look at how the system works. Let's start with taking a look at we are, after all, talking about Docker. So this is a Windocs host. So this is where we're building, these complex VHD-based clones. But it also supports standard Docker commands and Docker syntax. So you can see Docker PS gives me a return that gives me container IDs, tells me what image that container is using. So in this case, we've actually got 3 different images built. There's a clone to Linux SQL Server container. It's a SQL 2017 Linux container. I've actually got an environment here where I've got a clone to a SQL 2017 instance on the LAN. And I've got a local Windows SQL Server 2017 image as well. So 3 different images, all with the same data environment. You can see that the local SQL Server container started. The other 2 show a stopped status, but that's just the local view from a Docker perspective. These actually are environments that are mounted to the SQL Server Linux container and to the SQL Server instance that we have. Likewise, if we take a look, you can see the images are presented. And let's take a look on SQL Management Studio. Let's refresh the view. And you can see that we've got a data environment that is comprised of 4 different databases. This is the SQL Server instance, and this is the Linux SQL Server environment located at 192.168.80.10. And then down here, the 3rd environment is also running, and that's the local Windows SQL Server 2017 container. Now, let's take a look at a couple of other things. So I mentioned earlier that in the Windocs design, we've got, in this case, the databases are local to the host. It could be on an SMB or NFS file share. And you can see that the VHDs are also co-located with the backups. So I wouldn't be doing this unless I had relatively small databases in this case. But you can see the VHDs are being co-located, and then the differencing disks are also located in the same space. The differencing disks are notable by the GUID associated with each. And so you can see I've got 3 VHDs and I've got the backups here. And so let's go ahead and build an environment just to go through the workflow. So I know I've got the just want to find the that's the file, Docker file for the, so here's the Docker file for the environment that we want to build. Couple of things to note. The format of this Docker file is a bit different from what I showed earlier. You'll see that the environment variable of running the Docker file to create the container is actually following the from command. And the reason I can do that is that the Windows host is smart enough to recognize that the setup cloning command is a build time operation. So it's not going to rerun these commands on every container create. So I can actually put these anywhere in the Docker file. They'll be run once when the image is built, and they won't be run again until a new image is built. You can also apply differential backups to build, a sequence of images in this fashion. So let's go ahead and build this environment. You can see the format of the Docker file is more of a stringified form, but the parameters are all the same as what we looked at previously. So I'm going to go ahead and build that image. So let's call this the pass image, pass to Linux. And I'm just going to type out the path to this Docker file. And you can see the Docker file is being sent to the engine. It's the same Docker file that we just looked at. Now this will build in a pretty short order. And the reason it will build as quick as it does is the databases here are really trivial in size. So it's just not going to take very much time at all. As I noted earlier, if you're working with a lot of databases and if those databases aggregate to be hundreds of gigabytes or over a terabyte in size, this will not be a quick, simple build. This will be a time-consuming process. Now, the engine itself is multi-threaded, so it is responsive throughout, but this is a process that will generally be done during after hours or when use of the system is moderate at best. And this should return to us in just a minute now.
So, Paul, while we're waiting for this to finish, I have two questions.
Sure.
Will the clone work between different versions of SQL Server?
Yeah, that's a great question. Actually, one of the really nice use cases for clones is in a data migration. So you can imagine all the people that are looking at migrating SQL 2008 environments to a more current environment, be it SQL Server 2016 or 2017. You can use this to build an image, and then you can deliver the image to those target environments. And so that's really a good use case for migration. Simplifies the testing. So you can see the, what's the other question, Jan?
We can do it in the end if you want, or
no, go ahead.
Okay. It's a broad question, a general question. What are the requirements for the Windows server in a fairly large corporate environment running Windows Server 2016 VMs?
Well, the overhead associated with this process is really modest. We run Windows on a dual core 4 GB VM all the time for our testing purposes. And I've got many customers that run an 8-core 96 gig server, and they are supporting up to 30 active developers simultaneously on that environment. So to answer the question, the containerization and the cloning, can be run on very modest systems. If you're looking to build complex images, you will want to have a reasonable, 8-core or better configuration. Perhaps more importantly, you'll want to have fast storage in the form of, SSD disks. Will be very helpful to speed the image creation time.
Yeah.
But the requirements in terms of the configuration of the server can be quite modest. Now you can see the new image that we built is complete. So let's go ahead and let's try delivering this environment. So I'm just going to, there we go. So this is, if we go back to the Docker file, the delivery of the image, involves the runtime parameters that we looked at earlier. So we've got those here. The runtime parameter of the container port, the MS container SA password needs to be assigned, and then of course the image name. So let's just assign a new port here. I'll assign it port 10,600. I'm going to leave the previous SA password. And okay, pass to Linux is our new image name. And so what we're doing here is the engine is going out, it's parsing the image, the pass to Linux image. It's recognizing that, oh, I've got to create a differencing disk off of the parent VHD that is saved as part of that image. That cloned differencing disk is being exposed on a mount point on the Windows host. And the method that we're using to connect to the Linux SQL Server host is a mapped share, a file folder. So we've got, if you go back to the, we've got, Windows data folder on the Linux host, and it's mapped to this folder structure on the Windows host. So we're delivering the clone to a mount point on the Windows host that is then being seen on the Linux host, and then we automate the mounting of the databases to the target environment. And this should be done in just a matter of seconds here. Actually, the longest aspect of this process involves some wait time. We have to create the SQL Server container on the Linux host, and then we have to give it some time for the services to get started before we can effect the mount. So this takes about a minute in total.
Well, if you want, we have another question
Sure.
to take a minute. So how is Windows an advantage as a DB clone versus DB virtualization tool? So how is Windows an advantage as a DB clone tool versus a DB virtualization tool stacks such as Actifio and Delphix? And what use cases would we use Windows for versus these other tools?
Yeah, it's a great question. I love that question. Actifio and Delphix are Linux and Unix-based cloning environments. What they are really they are a storage system. Now, in the case of Delphix, you'll have a difficult time finding a Windows shop that will speak very positively about Delphix, and I'm just being frank. They have a pretty good reputation on Oracle, not such a good reputation for SQL Server support. The other notable thing about Delphix is it's a solution that starts at about $250,000, where the Windocs solution starts with a Docker-oriented solution that starts at $500 a month. So it's a huge price delta. And likewise with Actifio, there's a pretty significant price delta there. I've worked with customers that have evaluated Actifio and Delphix and Windocs. I have many customers that end up choosing Windocs. And really the advantage is that, number one, Windocs is a Docker design. So as you've seen, we have the database cloning and the SQL Server containers built into Windocs. The Actifio and Delphix solutions are really a storage array, and they require some pretty complex PowerShell scripting to use. Plus they're higher price and. So, that's a real quick answer to that question. But by all means, I would encourage you to try out these solutions. Number one, you won't be able to try out Delphix without a major project. Windocs is readily available. You can download it today and get started. Actifio is kind of in between, but not an easily downloaded software-based solution. Now, I'll also note that if someone has Actifio and they want to orchestrate delivery of data environments to SQL Server containers, I don't believe that's supported by Actifio today or by Delphix, but we'd be happy to support delivery of those environments off an Actifio storage appliance to SQL Server containers as well. So if any of you have Actifio deployed in your organization, we'd be happy to work with you. Okay, so the environment's been delivered. Let's check it out. So we're at port 10,600. Let's type in our assigned SA password. And there you have it. So that's your prototypical workflow. You start with your databases, you build an image, and once the image is built, you can provision environments. And this is really the beauty of combining database clones with SQL Server containers is, you can provision orchestrate, if you will, the delivery of the complete workflow with the containers, with the data, all in a matter of seconds. Now, another point I'll make is that this workflow, what we've gone through here today is a very Windocs-centric workflow. You can see, I'm working on the Windocs host. I'm using Windocs images. I'm provisioning environments with a Docker command line. Now, one of the things that we're doing is we're actually working on putting all of this workflow into a Docker standard image. So you can imagine going to Docker Hub, pulling an image that will automate the provisioning of the data on the back end from a Windocs cloning engine. So, we're not limited to a Windocs-centric point of view. I can support the same workflow from a SQL Server 2017 Docker image. We can also do the same for Kubernetes. We have plans to make this available as a Kubernetes data service that containers can take advantage of. I should also show you that we're not limited to strictly the Docker command line. We also have available a simple web UI. As you guys get more into the use of Docker, you'll find that a lot of developers and users don't want to deal with the Docker command line. So in the same way that we're using the Docker command line, you can see that we also can expose the image along with the target environment through a simple web UI. Now here, the runtime parameters that are needed are being prompted by the user. So in the case of a SQL Server or Linux host, we can simply enter a assigned port and the password. Now another thing that you can do is you can choose a subset of the image. We are parsing the image to expose to the users. You can use the whole image, or you can use a subset if you choose. And that would be most common, for example, in the case of using an image with a SQL Server instance. It would be fairly common for developers on a shared SQL Server instance to say, well, gosh, I see the updated image is available, but I'm really not ready to discard the prior databases. Let me mount a the updated database. And in this case, they could use this interface to select one or more databases that they want to work with to mount alongside of the existing databases on that instance. Now, the way we are able to do that is when this subset is selected through this selection tool, we'll append the date and time. The date and time stamp will be appended to the database name when it's delivered. And that way we avoid database name collisions in that use case. Are there any other questions that have come in, Jan?
Yeah, actually, one about masking sensitive data. Is that possible in Windows?
Yeah.
Or Windows?
Yeah, actually in the Docker file, you can run scripts on the databases. So it would be common to run scripts on the databases during the image build. The scripts could implement data masking, could be implementing support for database mail or any number of configuration requirements. We actually support the ability to run SQL Server scripts on the container prior to mounting databases as well. And database masking obviously is one of the top use cases for this. One thing that we're also planning on this fall is the ability to work with third-party data masking as well.
Okay. So is there actually a difference between Windows and the Docker option from SQL 2017?
Yeah, it's important to recognize that, so we haven't really looked at it, but this clone to a Windows container, this happens to be an image that I've built that's taking advantage of the Windows container engine. So Windows, this host that we're running here, I've got SQL Server 2017 running and supporting delivery of SQL Server 2017 containers. Now, our implementation of Docker for Windows-based SQL Server containers is different than what is available from Microsoft. And it's really beyond the scope of this session to get into a lot of details, but just briefly, I'll say that the Windows SQL Server engine, we create SQL Server containers that are an application instance only. So unlike other Docker implementations, we don't have any Windows footprint in the Windows SQL Server containers, just the SQL Server exe and any associated executables and DLLs. The result is that that container is lighter in weight. It scales better. It also provides better compatibility with existing enterprise infrastructure. So for example, one of the drawbacks of the Microsoft Windows SQL Server containers today is that they do not support Windows authentication. The Windows containers do. So yeah, the Windows containers and images are different than the Microsoft's built-in SQL Server Docker implementation. And, but having said all that, the cloning that we're really focusing on in this session, I can build a clone to Microsoft Windows containers. I haven't done that for our demonstration today, but it exists and it's readily available. It's part of our total solution. So you can see we have an image here that delivers to a Linux SQL Server container. We've got an image that delivers to the Windows local SQL Server container. We're delivering clones to a SQL Server instance on the LAN. And we could also add a delivery of the same environment to a Windows Microsoft SQL Server container. And I apologize for the confusion, but that is the reality. We've got competing implementations, so to speak.
Yeah, and isn't it true that you can also run older versions of SQL Server? For example,
Windows supports SQL Server 2008 forward, all editions. I think Microsoft's SQL Server image support is limited to SQL Server 2016 and 2017. As I spoke earlier, the opportunity now to create clonable images of SQL 2008 databases for testing against, any number of environments is one of the attractive use cases here.
Yeah, thought so as well. You
Go
can
ahead.
continue if you want. Yeah, I have two more questions about
Sure.
the binaries for SQL Server 2016. Do you just install them on the Windows server, or how does that work?
For those that are interested in Windows SQL Server containers, we create the containers by cloning a local instance. So you can, now the containers are going to reflect all aspects of that parent image, the instance that's cloned. So you can build containers using SQL Server Express or any of the SQL Server editions. So yeah, you would actually work with a designated instance on Windows to support, SQL 2016 containers.
Yeah, and it's all software based. There's no hardware appliances or anything like that.
No, this is all software based. That's one of the advantages over Delphix and Actifeel, although I think both Delphix and Actifeel also have software-based appliances, but they're significantly more expensive, and I think they don't deliver a native Docker workflow either, nor do I believe either of them support delivery of clones to containers. And I just wanted to, we're coming up to the top of the hour, so I just want to make sure people are aware. There are multiple resources available to learn more about database cloning. I'm not aware of very many people that build VHDs to support database clones, but I think it's certainly doable for the ambitious of you. So I'd point you, there's any number of references to working with VHDs on Microsoft's sites. The storage array vendors are also working to support the delivery of clones to containers and instances. Pure Storage has a recent blog on updated PowerShell scripts. And this is, the ubiquitous approach from the storage community is it's all about PowerShell. We think that the reliance on PowerShell is problematic for many customers. We have a lot of interest because people are tired of developing and maintaining and debugging, an extensive library of PowerShell scripts. And Redgate, a big supporter of SQL Pass, is also in the Windows-based VHD cloning. I don't believe that they support delivery to SQL Server containers currently, but certainly they should be on your list of things to look at if you're interested in database cloning. And just to wrap up, Windows, of course, we are doing database cloning from any source. So we're doing the VHD clones, but also any storage arrays. We're also supporting today delivery to any SQL Server targets, so SQL Server containers, instances, and Kubernetes clusters. And I invite all of you to download a free community edition at Windocs, windocs.com. We have a free community edition you can download. And with that, I think we're to the point where we can wrap up. Jan, any additional questions?
Yeah, last question before I can let you go. Are transparent database encryption databases supported in Windows?
Run that by me again, Jan.
Are transparent database encryption, so TDE databases, supported in Windows?
Yeah, absolutely. It's very, very common environments. Matter of fact, we have a global credit card payment processor that uses TDE encryption along with an external key manager with Windocs. So we've worked through virtually every enterprise infrastructure question I think that exists out there, and yeah, so TDE is certainly supported. You bet.
Okay, cool. I don't see any new questions coming in anymore. So
all right.
The only thing that's left for me to do is thank you all for attending, and thank you, Paul, for presenting this webinar.
Yeah, you bet. It was fun, Jan. And just one last note, if anyone has questions, I'm always happy to respond. My email address is pauls@windocs.com. Thank you very much, Jan, and thank you, the SQL Pass organization, for organizing this.
Yeah, indeed. See you next time, Paul.
Okay, bye-bye.